Chapter 5, Section 1, page 343. These problems similar to your homework problems. Alright, so let's start with number 1, evaluate 7 to the second power. So that means our base is 7, 2 is the exponent, so this is going to equal 7 times 7. And 7 times 7 we know is 49. And that's all there is to it. That's it. Okay. Next, remember this idea here. If I have kind of just going off on another type of problem here, if I have negative 3 to the second power, then this means my answer is going to be negative, and it's 3 to the second power, which is 3 times 3. Alright, and this is going to give me a negative answer of negative 9. Okay, as opposed to negative 3 in parentheses raised to the second power. Then this tells me, the math gods are telling us that negative 3 is the base. That's why they need to enclose it in the parentheses. So therefore this would be negative 3 times negative 3, which equals positive 9. Okay, so that is that. You don't have a problem like that in the homework, but I just wanted to run that by you. You can think about something like, what is the answer to, if I had written negative 2 to the fourth power? Okay, what is your answer to that? You can tell me in class if you like. Surprise me that someone's watching these. Okay, next is number 13. Number 13. Scroll down here a little bit. Number 13, we'll write it up. And this again is to evaluate x to the second power, and that is saying when x equals negative 2. Okay, so if x equals negative 2, then this expression here I'm going to rewrite to be negative 2, and I'm going to put that in parentheses because that's what x is, and it's a negative number raised to the second power. So by definition then this means negative 2 times negative 2, which is positive 4. Nice. Next problem is number 17. Scroll down. I got a nice yellow green blackboard, how would I call that? Blackboard. So this is going to be, that I'm using today, this is 2 times x y squared. And evaluate this when, let's see, this is saying when x equals 3 and when y equals negative 5. Okay, what is this going to be? So it's going to be 2 times x, which is 3, y squared, and y is negative 5, in parentheses, to the second power. Okay, so I know that negative 5 to the second power is 25, because it's negative 5 times negative 5, and that's going to be multiplied to 2 times 3, which is 6, and 6 times 25 is 150. Okay, not too bad. Okay, next is about the product rule, and we'll do number 21. What's the product rule? The product rule states that x to the second power times x to the 5th power is going to give me x to the 7th power. We're going to add the exponents. Okay, simple as that. The bases are the same, so we can add the exponents. And that's our result. Next, how about number 25? Just write it up real quick here. 25 is 5y to the 4th in parentheses, and that's multiplied to 3y. Case like this, I can do these are coefficients now, this 5 and this 3. So when I have this, I can do this separately from the variables. So in other words, let's do 5 times 3, which is 15, okay? And then y to the 4th to y to the 1 is going to give me y to the 5th. 4 plus the 1 is 5. So they'll try and trick you on that, because when we just write the variable, any variable, like x, they don't write the 1 there, but we know there's a 1 there. We just know it. Alright, so there's our solution for number 25. Next, let's try number 29. Okay, what's 29? Negative 8 m n to the 6 in parentheses, and that's going to be multiplied to 9 m squared and n squared. Okay, so here's our problem now. So again, do the coefficients separately. Negative 8 times 9 is negative 72. M times m to the second, put little ribbons here, m times m to the second, remember there's a 1 here. That's going to give me m to the 3. And n to the 6 times n to the second is n to the 8th. That's all we have to do. Done with that problem. Alright, here, now we're going to use what's called the power rule, which allows us to multiply this exponent that's on the outside to the exponents on the inside. So we give everything in the parentheses a exponent, so we can just kind of distribute the 3 to it. So this 2 really is to the power of 1, right? And then I've got a to the 5th. So I'm going to distribute the 3 to the 1 and multiply it. So that 2 becomes 2 to the 3rd. Put my equal sign, 2 to the 3rd, and then a to the 15th. Okay, and then I'll evaluate 2 to the 3rd, which is 2 times 2 times 2, which is 8, and then the a to the 15th is going to stay, a to the 15th. Okay? Remember our power rule, what it's stating, and why we can do this. The proof in this may be something like if I had 2 to the 3rd power, I'll do like so, raised to the 2nd power. Okay, so by definition, this means what's inside the parentheses, 2 to the 3rd times 2 to the 3rd. It's 2 of them, right? The base is 2 to the 3rd, and it's raised to the 2nd power. So it's 2 of these multiplied together. Now I'm going to bring out my product rule, which is the bases are the same, and then I add the exponents. 3 plus 3 is 6. So that example there gives me 2 to the 6th. And then looking back at the original problem, I can just say, oh, 2 times 3 is 6, which gives me that same 2 to the 6th. So that's why we're allowed to multiply the exponent of the power. It's a power raised to a power. All right, so that was what, number 39? Let's try something like 43. All right, here's 43. So I'm going to distribute this across, and this is going to be negative 7 to the second power. And that negative 7, see how it's in parentheses here, and it's going to remain in parentheses until I evaluate it. You could go ahead and do it now if you wanted to, but I'm teaching it and I just want to break it down for you. The rest of this is a to the, what is that? 2 times 2 is 4. B to the 2 times 5 is 10. And C to the, there's really a 1 there. 2 times 1 is 2. There you go. And then this negative 7 squared is negative 7 times negative 7. That's going to be 49. And then the rest stays the same. A to the 4th, B to the 10th, C squared. Okay, next problem. All right, here's the power rule. Again, using quotients. And the theory stays the same. And that is give everything an exponent here if it doesn't have one already. Like this negative 2 is to the first power, x is to the first power, and z is to the first power. That way I can distribute this 2 to all these exponents and multiply them together. So again, this negative 2 is in parentheses to start, so you could say that is going to be negative 2 in the parentheses raised to the second power times x to the second power times z to the second power, all 2 times 1, divided by y to the 10th. All right, and that just means that this negative 2 to the second power is just going to end up being 4. 4x squared, z squared, that's a z squared, over y to the 10th. No other simplifying that we can do there. Okay, so that one's done. Okay, here's our quotient rule. And the quotient rule says that we subtract the exponents. For multiplication, we add them. So for the quotient rule, which is division, we subtract the smaller variable, the smaller exponent from the larger one as a general rule. You're safer that way for when we get into negative exponents. So for this guy here, it's going to be what? P to the 7 minus 1, because there's really a 1 here, and times Q to the 20 minus 15. I'm just subtracting the smaller exponent from the larger one. And when I do that, then I can evaluate this a little further to say P to the 6th times Q, well, I'll do it this way, Q to the 5. And there. That's all we can do with that. Okay, simple as that. Okay, here are a bunch of examples to stress the zero power, where the base raised to a zero power is always 1. Similar to x to the 0 power equals 1. Okay, and then the variations of that when it's not 1. We think it's 1, but it's not 1. So let's just go through these and see if I've got them all. So I've got 7 to the 0 power. The base is 7. The exponent is 0. So this solution is 1. I got a 2-digit number, 123 to the 0 power. The base is 23 raised to the 0 power. So that is going to give me 1. They probably, my contention is with numbers, they should put them in parentheses. But that is the number 23 raised to the 0 power. Here we go. The base in this problem here is 2x, told to us by the parentheses, the use of parentheses. So if the base is 2x raised to the 0, this thing here equals 1. Here I've got 4y to the 0, similar to the 2x to the 0 in parentheses. So here my answer is 1. And now things change here a little bit right here. I've got negative 7x to the 0 power. So now I look at this as the 0 is, the base is x. And this exponent only applies to the base of x. So x to the 0 is 1. And then that's multiplied to the negative 7. So this in turn becomes and equals negative 7. It's like negative 7 times 1. The non-use of the parentheses. Just like this 4, if I go back to this 4. And if I wrote this up without the parentheses as 4y to the 0, then notice how my answer would change. My answer would be 4, this y to the 0 is 1, times 4. So this answer would become 4. Not 1 like this one with the use of parentheses. Okay, and finally, how about this one? Negative 7x to the 0. This just simply equals 1. It's all enclosed in parentheses. If it were written negative 7x to the 0 this way, then I'm going to have an answer of negative, oh, I did that one here, negative 7. Okay. Couple more little problems here for us to think about. 5 to the 0 equals 1 plus y to the 0 equals 1. So therefore 1 plus 1 is 2. How about this one? Negative 3 to the 0. Well, 0 to the third power. I don't have parentheses here, so but this is like 3 to the 0 power, which is 1. And this negative just comes along. Or you could write that up as negative 1 times 3 to the 0. Plus 4 to the 0. And 4 to the 0 is 1, positive 1. So this ends up being negative 1 plus 1, which is 0. Okay, there you go. A little more about 0 exponent.